Hi, everyone. We are Parallel Processing, and our group built a classification model to detect different levels of heart disease. And I'm going to pass it on to Max to get us started.
Heart disease is an extremely broad category. While there are several heart-specific diseases such as heart rhythm problems and congenital heart defects, several can influence the entire cardiovascular system. This includes all of the blood vessels that run throughout the body. In these blood vessels, several other diseases such as atherosclerosis can occur. If the heart can't pump blood properly, it will eventually cause functions in other parts of the body, especially the lungs and kidneys, to be disrupted. This disruption may lead to swelling in the legs, shortness of breath, and eventually heart failure. It's important to know how vital a properly functioning heart is, which only increases the imperativeness to prevent any heart disease by detecting the risk. There are two main types of risk factors for any medical condition: modifiable and non-modifiable. Modifiable risk factors are based on a person's life choices, such as diet and general lifestyle. Non-modifiable risk factors are based on factors out of an individual's control, such as family medical history, sex, and age. Both can cause equal susceptibility to heart problems, but only modifiable risk factors can be prevented and taken care of.
The following visualizations helped us find correlations among the columns, the number of columns, the size of our dataset, and a visual analysis of our data.
This is a correlation heat map that is used to determine which variables are correlated to one another and how strong the connection is. The color of the grid represents a positive or a negative correlation, and the shades indicate the strength of the correlation.
This bubble plot shows the correlation between a person's resting blood pressure and age. As you can see, the cluster is around people ages 40 to 65 with a resting blood pressure of 120 to 140.
This scatter plot compares the relationship between cholesterol and age. This scatter plot shows that when you get older, you have an increased risk of developing high cholesterol.
This is a cat plot that shows the correlation between phthalates and age while also showing the sex of the patients by the color of the dots.
This bar graph shows the connection between chest BPS and age. The top bar plot represents the men's data, while the bottom bar plot represents the women's data. The color indicates whether you are a target for or you are at risk for developing heart disease.
Our last visualization is a cat plot, and cat plots are used to show the relationship between a numerical and one or more categorical variables using visual representation. So this one shows the relation between the level of ST depression induced by exercise relative to rest in men and women, and some of the parameters include the names of the variables, colors for different elements, and more. So for our data set, we wanted to use data cleaning because it would be more suitable for machine learning models. And data cleaning is a process of fixing or removing incorrect or incorrectly formatted or incomplete data within a data set. And this helped improve the quality of the training data for analytics, and it enables accurate decision making. So some of the things that we did was removing null or missing values, taking out outliers that weren't used in the models, and we created easier and more simple data to read and understand.
We use machine learning for our models. Machine learning is a subfield of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being programmed to do so. The machine learning algorithms use historical data to predict new output values. The three main types used are supervised, unsupervised, and reinforced learning.
Random forest is a machine learning model that produces a high accuracy score for our dataset. It creates multiple decision trees and it takes the average output of each tree to make the final prediction. This model has a 93% accuracy score, and a confusion matrix was used to test its performance.
This is a support vector machine, or it's known as SVM, and there are supervised learning models with associated learning algorithms that can analyze data for classification and regression analysis. And it works by mapping the data to a high dimensional feature space so that data points can be categorized. And it's a linear model. And the accuracy for this was about 72%. And after running classification, after running a confusion matrix on it, it has 64 true positives, 27 false positives, 29 false negatives, and 85 true negatives.
Logistic regression is the third model we used. It predicts a binary outcome. It can predict a binary outcome based on the past data by examining the relationship between the target variable and the independent variables. The average accuracy of our model was in the upper 80%.
In conclusion, with the several different models we have coded, we can most likely assess with reliable accuracy a person's risk for heart disease. Well, as of now, the random forest model was most accurate, reaching 99% accuracy. We can continue to improve the other models and improve their accuracy as well. Additionally, we coped with a relatively small data set and minimal prior coding experience. So in the future, we can implement more AI and use this knowledge as a foundation to achieve greater results.
Okay, and then this is our team. We have Ava, Sid, Shriya, Ayden, Rocco, and Max. They didn't want to put their pictures in, so they just put in GIFs. But I just want to give a shout out to all of them because they were all first-time coders and they did a really good job developing this project. And that's it for our presentation.